Hi everyone, today's lesson is notes number 7 from Unit 1, and we will be taking a look at some proofs today. Now the title says that we're going to take a look at segment and angle proofs, and we will do one of each of those, but tonight's practice and learning check will focus on algebraic proofs. Right, so a two-column proof is a logical sequence of statements made to reach the conclusion we are trying to prove. So it's basically justifying all of your thoughts along the way. Every proof starts with a piece of given information, and this we see right here. It says we're given that angle 2 is congruent to angle 4. And in this particular proof, we're being asked to prove that angle 6 is congruent to angle 8. Now, we're going to come back to the proof of this in a few minutes. In your chart, it says sometimes we have to make conclusions about the given information. And this is basically what I want you to do when you're writing a proof. If, for instance, you're given a statement such as x minus 5 equals 10, then we can make the conclusion that x equals 10 because we know that we could add 5 to both sides of this equation to get x is equal to 15. And what we used was the addition property of equality. We added 5 to both sides. So think about each of the statements in the far left column and think about the conclusion you can make and then justify it with one of our properties from algebra. So if 7x is equal to 56, then we can make the conclusion that x is equal to 8 because I can divide both sides by 7. So I'm using the division property. In our next statement, you see that we have parentheses. And we would take that 7 and multiply it by everything inside to get 7x plus 21. And that's an example of the distributive property. The next statement says x plus 6 equals 9. Well, to solve that, we'd have to subtract 6 from both sides. We would end up with x is equal to 3. So we use the subtraction property of equality. The next one is a little different. So I'm just going to write the word if right here. If a equals b and b equals c, then our conclusion can be that a is equal to c. Right? First is equal to last. And that's an example of the transitive property. Alright, the next one's a little different as well. If 4x equals y and x is equal to 3, this is not the transitive property, then we can say 4 times 3 equals y, or 12 equals y. And what happened was we, or I, took out that x and replaced it with 3 right here. So that's substitution. All right, in our next example, if B is the midpoint of line segment AC, well, we know that means that it cuts it into two congruent parts. So I marked it in the diagram, but we can put it into writing as AB, line segment AB is congruent to line segment BC. All right, and we know that by definition of midpoint. And this gets used quite a bit in proofs. All right, the last one, I'm going to highlight this whole statement here. All right, very often students tend to skip over the directions or the given information, so make sure you slow down, read it closely, mark your diagram with it. It says that ray LN, that's this ray, bisects angle MLO. Well, to bisect an angle is to divide it into two congruent angles. So we could say angle MLN is congruent to angle OLN. and that's by definition of an angle bisector. Okay, next we'll take a look at how these things are actually used in proofs. Okay, in our first proof, this goes back to what we started our notes with. It says we're given that angle 2 is congruent to angle 4. So the given information usually goes first in your proof. Angle 2 is congruent to angle 4, and that was given. So we were told that. Well, what you want to do in a proof is see how you get to the next step. Okay, we're logically going from one step to the next. So if angle 2 is congruent to angle 4, hopefully it makes sense that they have the same measure. So all that's changing here is the congruent sign is becoming an equal sign. And the reason is that's the definition of congruent angles. Congruent angles have the same measure. So the definition of congruent angles tells us that if they're congruent, they have the same measure. Okay, just have to give you a heads up. There will be a couple little typos later on. Right. Now, in step 3, we have to take a look at the picture. This statement says the measure of angle 2 plus the measure of angle 6 equals 180. So here are angles 2 and 6. And we see that they form a straight line. So yeah, they would add up to 180. Likewise, it says the measure of angle 4 plus the measure of angle 8 equals 180. And they do form a straight line, so they're supplementary as well. The reason we can write these equations is the definition of linear pair. They are linear pairs of angles. Right? They're adjacent and they form a straight line. So they are a linear pair. Okay, typos. Line 4 should say the measure of angle 2 plus the measure of angle 6 equals the measure of angle 4 plus the measure of angle 8. Okay, so line 3 becomes line 4 because of the substitution property. You see how both of these are equal to 180? Well, if both sums are equal to 180, then it makes sense that the measure of angle 2 plus the measure of angle 6 is equal to the measure of angle 4 plus the measure of angle 8. So that is by substitution. Okay, to get from step 4 to step 5, notice that the measure of angle 2 disappears and the measure of angle 4 disappears. And here's what happens. Since angle 2 is equal to angle 4, we're going to subtract the measure of angle 2 from this side, and we're going to subtract the measure of angle 4 from this side. So to get to step 5, which says the measure of angle 6 is equal to the measure of angle 8, we would use subtraction. Alright, in step 6, because those two angles have the same measure, we can make the conclusion that angle 6 is congruent to angle 8. Alright, and that's the definition of congruent angles again. Alright, notice that we went back and we looked at the proof statement. Our last line has to match with the proof statement. Okay, the last one that we're going to do is this middle one. It says, given the measure of angle 1 plus the measure of angle 2 is equal to 132 degrees. So that this whole angle is 132. And also the measure of angle 2 is 105 degrees. We have to prove that the measure of angle 1 equals 27. Well, notice what's missing right off the bat is our first statement and our first reason in our proof. Okay, so look at your given information. Measure of angle 1 plus the measure of angle 2 equals 132, and also measure of angle 2 equals 105. If you're using the same reason for more than one piece of information, you can put it all together on the same line. Alright, next, from line 1 to line 2, there's a change in our equation. Notice that the measure of angle 2 is replaced by 105, and that's because of this statement right here. So what happened right there was that we used a little bit of substitution to rewrite the equation. Okay, next, going from line 2 to line 3, notice what happens is that we subtract 105 from both sides. And 132 minus 105 is indeed 27 degrees. So our last reason would be subtraction. Okay, we're going to skip the last proof here. You can go on to work on the practice number 7 and learning check number 7 posted for you in Google Classroom.